right, we are in another video for geometry. We are in section 11-4. We're going to be talking about volume now. So before we were talking about surface area, now we're moving on to volume of prisms and cylinders. And by the end of this video, I'd like for you to be able to calculate the area of prisms in multiple positions given limited information. So first of all, I want to remind you of what a prism is. It is a 3D solid with two parallel and congruent bases. Now, as a reminder, a base is essentially the face that the solid sits on, or the side that the solid sits on, to be facing upright. Because technically, you can take a box and turn it on its side, or you could take, I don't know, a container and not have it facing upright. But just because it's sitting on a different side does not mean that the base has all of a sudden changed necessarily. So that's a different way that you can think of the base. Volume is the amount of three-dimensional space that a solid is going to take up. So surface area is two-dimensional, volume is three-dimensional. So the amount of three-dimensional space a solid occupies or takes up. Now, I accidentally have surface area on here. We don't need to redefine surface area because we've done that in our previous videos. So with that being said, I do want to show you some formulas and some images just so you can see how this is going to work. We have lots of different types of prisms. I mean, there's more than triangular, rectangular, and pentagonal, but this is just so you can see what they look like. So first of all, a triangular prism, the formula for the volume is equal to base times height. And a triangular prism might look like this. They look lots of different ways as far as what type of triangle they're made out of. But this is just one way that it might look. Okay. And then the base, which is the triangular base, this part of it right here. The formula you're going to use for that, so notice this is big B is equal to 1/2 base times height, which is really weird because this looks so similar to this one. But here we're talking about the height of the triangle, the base of the triangle. It's the formula for the area of this little pink area right there. Okay, so now we also have a rectangular prism. The formula for the volume is once again base times height. A rectangular prism might look like this. And once again, their dimensions change. Sometimes they're short, sometimes they're tall. It's just kind of according to what the picture looks like. But the base in this scenario is a rectangle. And the formula for that is going to be base times height. Now, I know that's weird, like I said, but we're using formulas within formulas. We also have pentagonal prisms. Those are, once again, base times height. The pentagonal prism might look like this. Okay. And then big B is equal to 1/2 apothem perimeter. Now, the base of the pentagonal prism, or one of the bases, because technically prisms have two bases, is that part right there. Okay, and finally, we also have cylinders. Now, cylinders are also base times height, but the base looks different because it involves pi. And so the base is going to be pi r squared, and this is what cylinders basically look like. And like I said, we can draw lots of different examples where they look a little different, but in general, this is what we've got going on. So now let's just apply these formulas because from our previous units, we've had lots of vocab, so we can just go right into solving using these. We're going to find the volumes of some rectangular prisms. So right here, this is my rectangular prism, and we know that the formula is equal to big B times height. So volume is big B times height, and the base is going to be base times height, or length times width, whatever you want to think. So that is 3 times 5 in this picture, or 15. So now I can take this 15, plug it back into my formula. So I have volume is equal to 15, which is this bottom part of the shape. The 15 is the area of that. But then if I take that area and multiply it by how tall the shape is, which is 5, then I'm going to get the volume. And so when I take 15 times 5, I'm getting 75. Because my unit is in inches and I'm taking volume, it's going to be cubed. Because volume is 3-dimensional, so my unit needs to be in 3 dimensions, cubed. All right, let's find the area of this prism. Now, what's interesting about this one is this is an oblique prism. We talked about that in a couple sections prior. So it's still the same formula, base times height. But notice this is also on its side. Like I would consider this front base this front face that we see right here, the base of this. So we need to do volume is equal to base times height, and the base of this one is a parallelogram, but the formula for a parallelogram is still base times height. So the base of this parallelogram is 6, but the height is not 4. That is this slanted edge right here. The height, it looks like, is actually 8 because the height of the prism in this direction is like this. So it's going to be 6 times 8, which is 48. Because this is a box that's laying on its side, okay? Now, this area is only for this front face. I need to take this front face and multiply it by how long the prism is. Well, the prism is 10 long. So now I'm just going to put that into my whole formula. Volume is equal to big B, which is 48. We calculated that, multiplied by the whole height, which is going to be 10. And so volume is equal to 480 square units, or I mean cubic units. Okay, flipping that paper over, we can also find the volume of triangular or pentagonal prisms. It's just the thing that's going to change is what we consider the base to be, what shape is the base. So then what formula are we going to have to use to calculate the area of that base? We're still using the basic formula of big base times height, but we're going to have to use different formulas for whatever the big base is. So here, if we're applying volume is equal to big base times height, the big base in this image right here is a triangle. So it's a prism that's actually on its side. If we were to take this and to sit it upright, then the triangles would be the top and bottom, and these other 3 edges would be the lateral faces. So this base, I'm going to say, is this part of the prism. And that is the formula for the area of that is 1/2 base times height. So now if we apply that 1/2, the base of this triangle is 20, but we don't know the height. We need to calculate that. Now we do know 2 edges of this triangle because notice this 29 could carry over to right here as well. So what we've got going on is we know this bottom part is 20, we know this slanted side is 29, but what we need to figure out is the height of the triangle that is the base of the prism. So the way we're going to do that is by using the Pythagorean theorem. So just over to the side, we're going to do some scratch work. This is not the hypotenuse though, so we're not going to put this in the C value. The Pythagorean theorem is a squared plus b squared equals c squared. So we can call this side b if we want. So we've got 20 squared plus b squared is equal to 29 squared. When we square those, 20 squared is 400, plus b squared. And then 29 squared is 841. Okay, now we want to isolate b, so we're taking 400 and subtracting it from both sides. So we have b squared is 441. And then when we square root both sides, the square root of 441 is 21. Okay, that's helpful. What we just found out is that this side length right here is 21 long, and that's the height of the triangle. That's the base. So, and when I say base, I mean big B. So 20 times 21. Now we can find the actual area of the big B base. So when we take 1/2 times 20 times 21, we're going to get 210. Okay. Now at that point, we can take this, because this 210 is the value of big B in our formula. So we need to take big B times the height of the prism to figure out the volume of the prism. So volume is going to equal 210 times the height of the prism, which is 40, because once again, this prism, it's kind of like a block that got knocked over, okay? So this is how long or how tall the block would be if we sat it back up on this, okay? So we've got 210 times 40, and when we do that, we get 8,400, and then we're working in meters, so cubic meters. All right, let's find the volume of this other triangular prism. Once again, this triangle prism is on its side. The base is actually this triangle and also this triangle. These are the bases of the whole prism. Okay, so I'm going to label that for you. So it's, once again, it's kind of like a block that got knocked over. So we're still using this basic formula. This formula is the fundamental one that we use every single time, but based off of what the prism looks like, we adjust it a little bit to calculate the correct shape values. So we have volume is equal to big B, base times height, and then big B is 1/2 base times height. Now here we don't have to calculate anything because we have the height of the triangle right here, 8.3, and if we want to, we can carry that over to the other side. Because we know the two bases are gonna be the same size. They're congruent to each other, and the word congruent means same. So we have 1/2 times the base of the triangle, which is 10, times the height of the triangle, which is 8.3. Okay, when we multiply that, I'm getting 41.5. Okay, this 41.5 is the area of the big base. We need to take the area of the prism and multiply it by the height of the prism. Well, the height of the prism is how long it is. So it is 14 centimeters long. So we're gonna have volume is equal to 41.5 times 14. When we put that into our calculators, we get 581 cubic centimeters. So here, it's very, very similar to rectangular. It's just the base of the prism is a different shape. Next, we have a prism that is pentagonal, meaning it's got 5 sides. So we're still using the basic base times height, but the base is not a triangle like it was up here. So we're gonna have to use a different formula for that. The base of, or the area of a pentagon is not 1/2 base times height. It is 1/2 apothem perimeter. So when we plug into that, we are given the apothem, it's 3.4. And the perimeter is gonna be the distance all the way around that base, okay? So it's telling us right here that a side is 5. So all of these sides are 5. So it's 5 plus 5 plus 5 plus 5 plus 5. Now, because these are drawn in 3 dimensions, it doesn't always look like they're the same length to our eye because of that forced perspective. So all of these are 5. And when we take 5 times, we're going to get 25. Let's multiply that together. So 3.4 times 25 times 1/2, and we're getting 42.5. 42.5 is just the area of the big base. It's the area of this bottom part of the prism. We need to then take that area and multiply it by how tall the prism is. So now we're ready to put it into our volume formula. Volume is equal to 42.5, which is this number, the number we calculated for the base, multiplied by the height, which is going to be 11. When we multiply that together, we are getting 467.5. We don't have a unit, so I'll just say cubic units. All right. So those are all prism problems. What happens when you have a cylinder though? So cylinders, you approach it the same way. Volume is equal to base times height. So we always use this for volume. This is the fundamental formula. But what changes is what formula are we going to use for this B? Because the bases of our prisms is what's changing. So here, the base is a circle, so we're going to use the formula for a circle. So we've got volume is equal to base times height, and the base is going to be pi r squared. So we can go straight into substituting that in. 16 is telling us the diameter. If we only want the radius, we're going to have to take half of that, which is going to get us 8. So the radius is actually 8, not 16. So we're going to say pi times 8 squared, which is going to be 64 pi. I'm going to leave it in terms of pi for right now. So this 64 pi is equal to big B. This is the number that we have for the big B in our formula. Now we're ready to go straight to our volume formula, which is going to be 64 pi times the height of the cylinder. Well, the height of the cylinder is 9. Okay. So now we're ready to take 64 times 9 to get us 576. So the volume is 576 pi, I'm tacking that on there, and then cubic feet. Now this is in terms of pi, but if we were told, like say in an assignment or a test, that we were supposed to round, then that would clue us in to tell us, oh, okay, we need to put it into a decimal, so we can just take 576, multiply it by pi. Let me do that in my calculator. And we get 1,809.56 cubic feet. So this is a rounded answer. All right, let's do one last problem. We are finding the volume of an oblique cylinder. It is okay that it is slanted. We just need to know the height of it, and we have that height right here. So volume is going to equal base times height. The base is pi r squared, which is going to be pi times 5 squared, because this 5 right here is this radius. So that's going to get me 25 pi. That 25 pi, this right here, is big B, the base of the whole cylinder. So now I'm ready to say 25 pi times the height, which is 15. When I take 25 times 15, I'm getting 375. So the volume is 375 pi cubic centimeters. But if we wanted to put it in a decimal form, we could just take 375, multiply it by pi, and we're going to get 1,178.1 cubic centimeters. These are the same number, it's just one is an exact representation of it when we use the pi symbol, and one is rounded. And there you have it. Those are how you apply the volume formula for these different types of prisms and cylinders. I hope you have a great night, and if you have questions, be sure to ask them to me in class. Bye.